Okay, hey, welcome back. This is our third video on practice problems for electron configuration. This is the one where we go through electron spin. So this is where we put everything together so we can figure out, hey, is a certain electron spinning in the positive direction or negative direction? But before we get into the actual problems, here's just some key points. Remember your orbitals. S has one suborbital and it can have 2 electrons in it. P has 3 suborbitals. It can have 6 total electrons in it. D has 5 suborbitals and it can have a total of 10 electrons in it. F has 7 suborbitals and it can have a total of 14 electrons in it. Also, our rules for spin. First of all, when drawing out electron spin diagrams, an arrow pointing up or up spin is also known as positive spin, while an arrow pointing down or down spin is known as negative spin. Each suborbital must have one positively spinning electron in it before a negative one can be placed in it. So in other words, each suborbital in your orbital must have a positive electron in it before we can even think about adding negative electrons. And then negatively spinning electrons will fill the first open spot available. So after you filled in all your positive electrons, your negatively spinning electrons can be filled in their first open spot available. Another thing I want to show you, and I want to kind of keep all this on the board, is our periodic table orbitals. So basically what this is saying is, hey, we can see that these columns in this area have a valence shell with an s orbital, while these have d, and these have p, and these have f. It just helps you with doing these types of problems, knowing what the most outermost layers are going to be. In saying all that, let's start working some practice problems. So for all these elements, we are going to draw the electron spin diagram for the valence shell of all these elements. So first element we're going to talk about is zinc. It is in the d orbital section on our periodic table. So if we look at the transition metal, that's in our middle section. It's in our d orbital section. Its quantum number is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Okay, so its valence shell, or its outermost shell, is our 3d orbital. And our d orbital has 5 suborbitals in it for a total of 10 electrons. Zinc has a fully filled d orbital, as we can see through the quantum number, the 10 of the 3d portion. Because of that, we are going to fill up our 5 suborbitals with positively spinning electrons first, or upwardly spinning electrons. Then we are going to add 5 negatively or downwardly spinning electrons to the mix. And that's all you have to do with these. We've got our quantum number. From our quantum number, we can find our valence shell. Our valence shell, then we can start filling in the spin diagram. Okay, let's go to calcium. Calcium is found in the S section of the periodic table, and it has 20 total electrons. Its quantum number is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay, so its valence shell is the s orbital, the 4s. Okay, so that means it's going to have 1 suborbital. It can have 2 total electrons, which it does because it's 4s2. So we're going to have 1 positively spinning electron in this orbital and 1 negatively spinning electron in this orbital. Lead is our next one. Lead has 82 electrons and is found in our p orbital. So if we go through this, we have a quantum number of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, and 6p2. Okay, so this is the first one we see that does not have a filled valence shell, or our p shell in this case. Since the p orbital has 3 suborbitals, and that can hold a total of 6 electrons. And we only have 2 electrons we can put in. Obviously, we can't fill this up. So we are going to have to follow our rules about electron configuration and understand that we're going to have to fill our positive or upward spinning electrons first. That means our 2 electrons in the p orbital are going to be spinning upwards or in the positive direction, 1 on each of those 2 of the 3 subsections. Okay, so another type of question you may see with electron spin is to determine whether a specific electron within an element on its valence shell is spinning in the positive or negative direction. And that's what we're going to do on this one. So for instance, if I'm trying to figure out the 4th valence electron in a sulfur atom and figure out if it's spinning positively or negatively, I'm going to go and first figure out its quantum number. Sulfur has p valence orbital. Once we do its quantum number out, we find that it has 5 valence electrons in that orbital. We want to know the 4th one. So we are going to fill our positive spinning electrons first. So remember, p orbital has 3 suborbitals, so that's 3 positively spinning electrons. So there's 3 of them. We're wanting to know the 4th one. So we're going to go add 1 more. Since we filled our positively spinning electrons, now we got to add our negatively spinning electrons. We only have 1 to add, so it's going to add to the first open spot, and that answers our question. We're wanting to know what is the spin of the 4th valence electron in sulfur. Well, it spins in the downward or negative section. So that's the electron we're looking for. We don't have to go any farther on it. What about zirconium? We want to try to find the 2nd valence electron in zirconium. Well, zirconium is found in the d orbital, and if we do the quantum number for it, we are going to find 4d2 for that valence shell. Our first rule states that we must fill our positively spinning electrons in our suborbitals first. We have 5 suborbitals in the d orbital. So since we only have 2 electrons here, both of them are going to be positively spinning. I hope these helped you out and gave you a little bit of a better understanding of electron spin diagrams. That's all I got for you as far as just types of problems working with these. Keep up the good work and see you next time.